Good morning, friends. Welcome to the series of Multiplexer. Till the last video, I have covered how to implement the various multiplication or can say various functions of basic gates and other functions with the use of multiplexers. Now, in this particular lecture, I am going to implement the higher MUX using the lower order MUX. Suppose the example is if I want to implement simple 4 is to 1 MUX using 2 is to 1 MUX. Okay. So this is the example of implementation of higher order MUX using the lower order. So what is the general structure of 4 is to 1 MUX? In 4 is to 1 MUX, we have 4 inputs on the basis of the 2 select lines and 1 output. It is 4 is to 1. But on the other hand, in 2 is to 1, there is 1 select line and 2 inputs, 1 output. It means to create 4 inputs and 2 select lines, we have to use 2 is to 1 MUX to get the same. But the problem is, if I take 2 is to 1 MUX, this is the select line, which I am taking as S. And this is the input I0. This is the input I1. These two inputs are I2 and I3. So for these two multiplexer, there are 2 inputs, 1 select line S, 2 inputs, 1 select line S for second also. But now matching things is, we have matched with the inputs only. Input of 4 is to 1 are 4. And by using these two multiplexers of 2 is to 1, we have 4 inputs. And only one select line is used till point. So we need one more select lines and one output. Up to this point, we have 2 outputs as well. So for getting one output, we have to use one more multiplexer, 2 is to 1 multiplex. If you use one more 2 is to 1 multiplexer, here we will use select line 0. Suppose this is select line 1. So this is also 2 is to 1 MUX. And finally, we have the function 1 output. So I can say, if we draw this architecture, if we look at this architecture, then we can see that, suppose I am writing this select line not here, but instead of it, I am writing or I am drawing this select line at this point. So S1, same select line is getting inside the upper MUX as well. And this S0 here. So what this structure is looking like? What this structure is looking like? It is simply looking like as the 4 is to 1 multiplexer. If you compare with it, there are 2 select lines. So these are 2 select lines and there are 4 inputs and 1 output. So it means it is an implementation of 4 is to 1 MUX using 2 is to 1 MUX. So how many 2 is to 1 MUX are required? There are 3 2 is to 1 MUX are required for the implementation of 1 4 is to 1 MUX. A similar thing can be done for 8 is to 1 MUX. If I'm extending this concept to 8 is to 1 MUX, so what is the basic structure of 8 is to 1 MUX? So this is the 8 is to 1 MUX. For this, we have 3 select lines, S2, S1 and S0. And on the basis of it, we have 8 input lines. from I0 to I7 and one output. 8 is to 1 MUX. Now we have to create these three things. First of all, we should have 8 inputs and we should have 3 select lines and 1 output. And if I am using the array of 2 is to 1 MUX, then for creating, first of all, we have to create the 8 inputs. So for creating 8 inputs, so our first motive is to create the inputs. Whatever the inputs we have required, create this number of the inputs. So for creating 8 inputs using 2 is to 1 MUX, we have to take 4 2 is to 1 MUX. 1. So this is the first stage of array of multiplexers. So these are 2 is to 1 MUX. 1, 2, 3, 4, 5, 6, 7, 8. So total 8 inputs are there from I0, I1 till the point I7. Okay. So these are the 2 is to 1 MUX and only one select line is required. So let I am taking it as S2. Now the point is we have one select line covered S2 and all 8 inputs are covered. So we are free from the side of inputs. Now our motive is to use 2 more select lines S1 and S0 and we have to create one output. So out of these we have 1, 2, 3 and 4 outputs. But the point is we can club two outputs with a one more stage of 2 is to 1 MUX. I mean to say that if I use one stage of 2 is to 1 MUX here, we can fed these outputs as an input of these two multiplexers. So this is the second stage, which will use your S1 as a select line, and these are the intermediate inputs, or can say outputs of first stage multiplexers. Now we have two outputs which can fed inside one more multiplexer, 2 is to 1 multiplexer, which has a select line S0. In the final, we have the output function F. So we can simply see it. We can simply see it. Now, three select lines are available, 8 inputs are available, and one output is there. So this complete structure is nothing but the implementation of 8 is to 1 MUX using 2 is to 1 MUX. So the point to remember is that, yes. So the point to remember is that, first of all, match the inputs. Match the number of inputs. Second, match the number of select lines. And third, try to get only one output. Only one output. So sometime it may possible that we will not able to draw the one output. We will take the further examples in which I will use 4 is to 1 multiplexer to implement 8 is to 1 MUX. We will see there whatever the problem I am talking about, you will see in next video. So this is enough for this video. Thank you.